And for the rest, yeah, it was an awesome tutorial, no bugs whatsoever. So, actually this talk covers what I'm trying to do in my PhD thesis, which is support intelligent elasticity control. Everybody wants to do control of elasticity across services, wants to add, wants to remove things, but more often than not, we have a problem in supporting the control mechanisms with the needed information, the needed monitoring information, or the needed information for pre-deployment. So, so we will first go into, before having a runtime application, what would we like to have in terms of supporting our future runtime elasticity control, and then go into something that I've been investigating in terms of runtime monitoring and analysis of elastic applications. So the main issue is that you would like to have such a service. You have, of course, some fixed points like that are not elastic, a load balancer, maybe a data controller. They stay as they are. And then you have places where you have horizontal scalability. You can add, remove instances. And, well, if you want to deploy such a service directly in a cloud, well, for the static part is a bit easier. You look into all the provided services. This cost per hour is good, this cost per gigabyte of data transfer is good, I pick it. But for the elastic part, now if I want to deploy an event processing instance, then will I choose a micro type of service, a virtual machine that gives me 3 types of what I call elasticity capabilities. So at runtime, I can instantiate a new micro with on-demand price or on spot, or I can reserve it for 1 year or 3 years. But if I choose such a service, I'm also bound in Amazon to use an elastic block store. This is mandatory for this particular type of virtual machine, or it wasn't the last time I checked. The other option would be to go with a different type of service for which I can optionally select an elastic block store, but which has less cost options. So at runtime, I can only choose on demand when I have horizontal scale, I cannot use spot. So depending if that's important for me or not as a developer that has some elasticity in mind, knows that at runtime I will want to have quality elasticity or cost elasticity to choose between different type of cost options when I instantiate new resources. I'm trying to provide here a, let's say, integrated flow where you have some cloud services that are described in a repository, and this description also contains their elasticity capabilities, what you can do. And then, of course, based on some specific service requirements, specific elasticity requirements due to envisioned design schemes, provide a recommendation. In the end, it can be in terms of a deployment descriptor that is interpretable by a cloud or a cloud provider, in which we say if you use these services, you might have this elasticity, or if you use another services configuration, you will have other elasticity properties that you can use at runtime. The core concept here is the elasticity capability, and if you have the example, you have one tiny, then an elasticity capability could be cost. We view elasticity for any service as reconfiguration possibilities with respect to 3 main dimensions, with cost, quality, and resources. And more often than not, you configure resources to achieve some cost or quality aspects, but you should also be able to configure cost directly or quality directly if a service has some capabilities like that. So for example, if a capability is cost, a capability also has some, when can you use it, so a phase, either instantiation or runtime, and it can have dependencies. In this case, cost could have 3 elasticity dependencies, each with different volatility. And volatility is something really important that we consider when we control an elastic service. The volatility should be the rate at which I can reconfigure that particular service. Because if I have a service unit that I want to scale every hour, and I reserve a service that can be reconfigured only on a monthly basis, then that's not supporting my design control mechanism. So. Of course, something also important that can increase or decrease the elasticity of a service is if the capability is mandatory or optional. So if it's mandatory, it means I actually need to always use that dependency. Maybe always use a particular resource like elastic block store. Or if the capability is optional, it actually increases the elasticity of that offer service. A latent elasticity, if you like. To select services that provide the required elasticity that we would like to have, we thought of quantifying these properties of an elasticity capability to imply some sort of quantification or a numerical ordering to be able to sort the services based on if it's important for the service to be to be reconfigurable, so elastic at instantiation time or runtime. If it is a big problem if we have mandatory associations, or it's a small problem, depending on what you want. To be able to quantify volatility, this is something more tricky, that's why it's left to the specification of each individual service. But it's something that is usually the rate at which I can change the service, evaluate it somehow, you'll see it later. And then have everything weighted, of course, with respect to each elasticity dimension, cost, quality, or resources. And this would provide a numerical value that should give me what I want in terms of elasticity. So by configuring this, I should be able to at least select some services that are appropriate for some type of particular control that I'm envisioning. So for example, if you look at Amazon, and if we quantify simply elasticity phase, for example, 1, 2, 3, depending on the phase, 1 minus 1 if optional or mandatory, the dependencies. There is one particular service, this one T1 micro, that has, is the only one currently that has service association elasticity -1 because you need to use elastic block store. But also if you look over them in terms of cost elasticity, some of them have only one cost option at runtime, some of them have two cost options, and some three. And while, of course, this is very simple because current cloud providers do not actually focus a lot on these capabilities, it's actually, even in this simple case, it matters if you want to have more cost options, then this service will be a better one for you. Because at runtime you have finer grain elasticity control. And just to have a, let's say, overview of what we do as a result, if you have a service that is defined by topologies and you have individual units, then for each individual unit you want to select services that provide the necessary capabilities. And in this particular framework we output in a winery, in a Tosca format that it can be visualized in Wine. Now after you have everything deployed, running, excellent, you want to monitor elastic cloud services. And this is a traditional problem that we encounter when we started this work a couple of years ago almost. You have service level monitoring, response time whatever, and system level monitoring, but not a lot of connections between them. So if the cost per client is too high, why? Is the system underloaded or overloaded? How do I need to scale it up or down? So the idea was to impose a logical structuring over the monitoring data that you can collect from also the virtual machine level, the system level, and the application level, and aggregate the data, connect that data with respect to the service structure that you are controlling and analyzing. So for example, if you would like to get a metric cost per client per hour, you would need some basic information, number of virtual machines per service unit, multiplied by cost per virtual machine, get some application level metrics like number of active connections or throughput, and combine them using what we do here is we use a set of metric composition rules to obtain some also higher level metrics, intermediary level metrics, and also the lower level metrics to have a complete view over the behavior of an elastic service. And then this enables us to put requirements, constraint, and control at the topology level, the unit level, or at the whole cloud service level. Now, after we have this, it's nice, but now there is another problem. The problem with requirements. And given that I have an elastic service, and I have an owner of an elastic service, wants to deploy it, wants to control it, and he knows these two requirements. A response time, 1 second, it's usually standard accepted, and it has some predefined pricing scheme. It's someone that wants to expose his service, and one client should pay like this. So he wants to also make a profit. The problem is when to scale event processing, what would be exact requirements, and when to scale the data. This is an issue for which we introduced the concept of elasticity space. So when you monitor an elastic service that is controlled, scales in, scales out, it leaves some sort of a monitoring space behind it. And depending on the requirements that you impose, these are user-defined elasticity boundaries. If the system or service goes out of these boundaries, it's not elastic anymore. So based on these boundaries, we are trying to determine other boundaries for all the other units in the service and all the other topologies, so that we can actually control. So from a cost requirement to get something that an elasticity controller can understand. Response time, CPU usage, memory, latency, everything. So for example, if we take a very simple elasticity space that monitors just 3 metrics, clients, throughput, and response time, you might have a requirement for response time, the upper one. And then we record for all the metrics monitored in the system, for all the requirements that we got, what were the upper, so maximum and minimum encounter values when those requirements were fulfilled. And for example, here you can detect a lower bound on response time, which might be interesting, but that actually indicates a lower bound where your system is underused and you're wasting money because it's underused. And going from this, you can also determine boundaries on other metrics, on all the other metrics in the system. And then if you have any elasticity capability that you can enforce, you can control on any metric on which you know some boundaries, then you can start controlling the service. And it's actually a point where we're trying to get some finer requirements from even generic ones to help someone to control such an elastic service. Now, an elasticity pathway is something that should help you understand, in terms of the elasticity controller, how will the system behave over time. Of course, this is a, let's say, simple implementation. It uses self-organizing maps, but it still gives an insight and says, okay, in 11% of the situation, you have relatively high response time, you have this throughput, and this number of clients. Which, of course, depending on the service you want to control, might be important or not. Now, after you have everything running, you can control. Another issue, and this is more future work or current but just starting, is you have the elasticity space. You have the behavior in time. You know this should be maximum and minimum on this metric or on that metric. So if I enforce an elasticity capability, or if there is a change in load in the system, what is the behavior of the metrics with respect to their elasticity boundaries? What does it mean? So it's not what will be the value of the new metric, but if I have an action applied on this, or if I change the load here or anywhere, and if I move out this part from elasticity, from its elasticity boundaries, what other elements of the service would also move out? And at what rate? With which attenuation function, or in which delay function? And this is something that is currently an open question that we are trying to address. And we need to think this will be really important in refining our existing control mechanisms that we developed in the laboratory by other people. Because it's important to do predictive control, not only reactive. Also, reactive control is difficult, but predictive is the key to actually achieve something that is usable outside of a research prototype. Just so I don't waste too much of your time, the concepts of elasticity, space, boundary, and pathway is something that we believe it's important in actually describing the behavior of any service that goes through some sort of elasticity control mechanism. Any service should have elasticity capabilities which are important in quantifying the latent elasticity in cloud offer services. So you can select the appropriate services to build something that supports what you want in terms of elasticity. And also the dependencies will be important or will be important in having actually predictive control mechanisms. And ensuring that you maintain an elasticity, not that you react when a boundary is violated. Because that also leaves periods of time where the service does not behave appropriately. And there are some tools developed in this work. Let's say less functional, fully functional, but we are working on everything. Thank you very much for it.
Any questions? So the question I would have, can you tell us a little bit about the implementation project? So how are they applicable as a framework for the local testing system? What kind of
So this is a framework to which you describe currently. So someone describes a repository of cloud services with their elasticity capabilities and dependencies.
language to describe elasticity capabilities?
It's a Nixon representation. Well, we don't like that, but yeah, we have a model based on actually. So okay, it was exactly this thing. So we have an XML representation that supports this. You can define one service with different types. And then you can also define some quantification coefficients. It's configuring your system. This tool, actually. And then you can also specify requirements. Currently, you can specify for each individual unit. So if I want one particular VM and one particular messaging service, and then it builds something that is currently a toaster representation that is visualizable like this. You have one virtual machine with monitoring service, and it's this monitoring service with this cost option that was selected because you wanted something. Well, it's a prototype implementation, so it's reasonable.